Hello, Advanced Algebra students. Ms. Backfish here, and I am wanting to look at this particular problem with you. It says a rectangular swimming pool measures 25 meters by 6 meters. It is surrounded by a path of uniform width, meaning it's the same width all the way around. If the area of the path is 102 square meters, find the width of the path. So this is actually sort of adjacent to the types of word problems we often do with quadratics, where we are trying to maximize something, like what is the maximum height of something thrown up in the air, or what is the maximum area you can enclose in a certain rectangle. But this is not asking what the maximum is. This is telling me what the actual area is. So this is actually not as abstract as that, or not as much to investigate. We're just really just solving here. So it says a rectangular swimming pool is 25 meters by 6 meters. So I'm going to draw this a little bit bigger. Sorry for not having a perfect rectangle, but that's pretty close. 25 meters by 6 meters. Okay. And then they're talking about a concrete path. It's kind of like the pool deck of uniform width. So they're saying it's the same width all the way around. So in other words, like the amount of concrete from here to the edge where you can plant flowers stays the same all the way around, is what we're putting around it. Okay, so there's just a piece of concrete that goes all the way around, like the edges of the pool. So they're saying that's the same width. So whatever this width is, it's the same here, same width, same over here, all the way around. It never changes. Okay. Then it says the area of the path. So we're really looking at the area. We don't care about the pool. We don't care about the pool. We're looking for the area of this portion. Okay. You can think of it like, I just made a shape that's kind of like my path. So it's like we're looking at how much paper is used here. What's the area of the amount of paper used to make this shape? Okay. So if the pool is 25 meters wide, then what we're going to do is we're going to kind of divide this up. Let me borrow a pencil over here. I could say that from here to here is 25, right? And then on either side of that, we have this width. It's the same down here. So whatever the width is, whatever W is, we've got that part here, and we've got that part here. Okay. Then I can look at this size here. So I've got, let's extend these. From here to here is 6. And then above that, I've got a width of W. And below that, I also have a width of W. So what I'm going to do is I'm going to think about that whole outer area. And then I'm going to, almost like what I've done here was I cut out the paper in the middle. I folded this and cut. I'm going to do the whole big rectangle and then cut out the middle part. Meaning I'm going to say, well, the area of the whole thing, and let me adjust this a little bit so I can see it better. Sorry about that. I thought I paused and apparently not. Anyway, the area of the whole thing is this distance here by this distance here. I mean, when I say the whole thing, I mean the outer rectangle, like that whole outer rectangle. All right, so this distance here is 25 plus 2W. W, 25. So that's the entire distance here. Sorry, to here, I guess. And this distance is 6 plus 2W. 6 plus W plus W. So that whole outer rectangle has dimensions 25 plus 2W and 6 plus 2W. So the area of the big rectangle, let's say the whole outer, is 25 plus 2W times 6 plus 2W. And I can use FOIL, multiply that out. 25 times 6 is 150. 25 times 2W is 50W. 2W times 6 is 12W, so that's going to add together to be 62W. And then 2W times 2W is 4W squared. Okay, so I'm going to turn that around just because we like to write our quadratics, which is what this is, because W is squared. We like to write them in standard form. Okay, so that's the area of that whole part that I shaded in orange, including the concrete edging and the place where the water goes, all of that. But since I know that the place where the water goes is this amount, I can subtract that out. So the area for just where the water goes, so the area of the pool, the part that holds the water, is 25 by 6, and that's 150, excuse me. Okay, so the area of just the walkway is the area of the whole thing that we came up with right here, minus the area of the pool, which we said is just this. So 4W squared plus 62W plus 150 minus the 150. So that's just 4W squared plus 62W. That's the area of the walkway. Okay? So what? Well, so they told me the area of the walkway is equal to 102 square meters. Okay, so that means that this amount that I just came up with is equal to 102 square meters. So 4W squared plus 62W equals 102 square meters. So I'm supposed to be solving for the width of the walkway. So I'm solving a quadratic. I'm going to do the same thing we always do, which is let's get it all on one side equals 0 on the other. And then if I wanted to, I could divide 4 out here, but you don't have to. I mean, I kind of think I want to because it makes it a little simpler, but you could use quadratic formula. Just from here, you could say A is 4, B is 62, C is negative 102. You could factor. I'm going to go ahead and take out 4. Actually, I don't think this is divisible by 4. And neither is that. You could take out 2, make it a little bit smaller. A little bit nicer numbers to deal with. And I'm going to use the quadratic formula. Why not? Again, you can use either one of these. If you don't understand why I went to here, you don't have to. Just use this one. But I'm going to do negative opposite of B plus or minus square root of B squared minus 4 times A times C all over 2 times A, which is negative 31 plus or minus. Let's see what 31 squared is. Let's see where I put my calculator. Okay, so here's what I get for underneath the radical. 2 times 2 is 4. Let's see if this is a perfect square. It is. That's the square of 37. So I get negative 32 plus or minus 37 all over 4. So that gives me 2 answers. Negative 31 plus 37 all over 4. That is 6 over 4, which is 1.5. Or negative 31 minus 37 all over 4. I can tell you right now that this is not going to be it. Why? That top number is going to be negative. A negative divided by a positive is a negative. We don't need a negative walkway width. So it turns out that this is my answer for the width of the walkway, and then I can go back and look at what the units were. According to this and this, we're dealing in meters. So my answer is 1.5 meters wide is how wide my walkway is.